Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at operations with terms. So we're going to look at multiplying, dividing, adding, and subtracting algebraic terms. So firstly, we need to know the definition of like terms. So two terms are said to be like terms if they have the same sequence of pronumerals, the same sequence of letters. So for example, 4x and 5x are like terms. They have the same pronumerals. They both have an x. On the other hand, something like 7ab and 2ba, they are like terms. Even though the A and the B are written in a different order, it doesn't matter because, as we know in algebra, if no operation's written, it means times. This is 7 times A times B. This is 2 times B times A. The order of multiplication doesn't matter. That's why A times B and B times A are literally the same thing, and that's why these two are like terms. Also note that numbers that have no pronumerals, so we call them constant terms, they are also like terms. So for example, 8 and -3 are like terms. On the other hand, something like 3x and 3y are unlike terms. They're not like terms because they have different pronumerals. Something like 3x and 3x squared, they're actually unlike terms. You might be thinking, well, hang on, they both have an x. But this one has an x, this has two x's. 3x squared is 3 times x times x. So because this has two x's, this only has one x, they are not like terms. They have to have the exact same sequence of pronumerals. So something like 7ab and let's say 12bc, they're not like terms. Yes, they both have a b, but this term has an a, whereas this term has a c. So only like terms if they have the exact same sequence of pronumerals. So why am I telling you this? Well, it turns out we can only add or subtract terms if they are like terms. If they're not like terms, we can't add or subtract. So when you do add or subtract terms, you have to find the like terms and then add or subtract the coefficients. So what do I mean by that? Well, remember coefficient means number in front of. So in this expression here, the coefficient of this x is 5. Now the coefficient of this x is 1. X and 1x are the same thing. B and 1b are the same thing. xy and 1xy are the same thing. If there's no number in front of a pronumeral, you can assume it's 1. So these two terms are clearly like terms because they both have 1x. They have the same sequence of pronumerals. So to add them together, we're just going to add the coefficients. So 5 plus 1 is 6. Coefficient means number in front of. We just added those together to get 6, and then we write the pronumerals, 6x, and then we're done. So let's look at 12y minus 5y. Well, these two are clearly like terms, same sequence of pronumerals, both of them have a y. So that means we can subtract them. So when you subtract them, we're going to subtract the coefficients. So the coefficient, or number in front of, is 12 here. It's -5 there. 12 minus 5 equals 7. Now, what a lot of people do wrong when they're subtracting terms is they cross out the y's. That's actually incorrect. We can't cancel the y's like that. This is like saying if you had 12 y's and you took away 5 y's, you would have 7 y's back. When we are subtracting terms, we don't get rid of the pronumeral, we still write it. All right, let's look at simplifying this expression here. It's a little more complicated. So there are 1, 2, 3, 4 terms. We have to identify the like terms. So it turns out that this term here, 12ab, and this term here, it's not 6ba, it's -6ba. They are like terms because they both have 1a and 1b. It doesn't matter the order in which they're written. On the other hand, it turns out that these two, -7b and -8b, are like terms. So what we're going to do is we're going to add or subtract the two blue terms together and then do the yellow terms separately. We do each set of like terms separately. So this is 12ab subtract 6ba. 12 minus 6 is just 6. And then we write the pronumerals. It doesn't matter whether you write AB or BA there. Now we're going to do negative 7b subtract 8b. While we're subtracting, we just operate on the coefficients. Negative 7 subtract 8 is negative 15, and then we write the pronumeral. We don't cancel or cross out the pronumeral when subtracting. So this expression here cannot be simplified any further. This term 6ab, this term negative 15b, they are not like terms because this one has an a, this one doesn't. They don't have the same sequence of pronumerals, so you can't add or subtract them. So my final answer is this. I can't do anything more to simplify it. All right, let's now look at multiplying and dividing terms. So you might be pleased to know that multiplying and dividing terms is generally easier because you can multiply or divide terms even if they are not like terms. And similar to what was on the previous slide, we just multiply or divide the coefficients. So we have here 7k and 2. They are clearly not like terms, but I can still multiply them. You see, timesing by 2 is the same as adding something to itself. So 7k times 2 is just 7k added to itself. Well, hang on, these two are like terms. So 7k plus 7k, I just add the coefficients, write the pronumeral. Of course, a quicker way I could have gone from here to here is just gone 7 times 2 is 14, and then wrote the pronumeral. But I just wanted to illustrate to you why we can multiply or divide terms even if they're not like terms. So it works similarly for division. 30m divided by 10. Well, I'm just going to go 30 divided by 10 is 3 and then write the pronumeral. What about this one that looks more complicated? 4a negative 3bc. These two are not like terms, but I can still multiply them. 4 times negative 3 is negative 12, and then I just write the pronumerals. I can do this because the order of multiplication doesn't matter. So I multiply the coefficients first, then write the pronumerals. What about 40ab divided by 8a? Well, this is a little trickier. Sometimes it's easier to write the division sign as a fraction line. 40ab divided by 8a. Well, we're still following the same process. So 40 divided by 8 is 5. But if we have an a on the top and the bottom, we cross it out. That's cancelling. So the a's here actually disappear, and I'm left with a b. The final answer is 5b. All right, what about this last one? 3x and 5xy. Again, not like terms, but I can still multiply them. I multiply the coefficients. 3 times 5 is 15. Now, x times x is actually x squared. So I'm going to write x squared and then just write the y. There, I am done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.